And to present myself, my name is Ivica Crnkovic. I'm professor in software engineering at Chalmers University and a member of Software Center. And what I would like to present here is the current expectation and state and challenges in using AI in industry today. So let us start with the AI hype, which we know now for several years, maybe 5 years, which started with big, huge expectations and enormous enthusiasms, and somewhat about scary stories about the problem in the future for mankind. And such big expectations have been changed in some cases as the solution to them, but also at the same time identification of the real problems and tough challenges which must be solved to get the AI approach properly working. We have also experienced misuse of AI. Remember just many cases from social media and the question of democracy and fake news and similar. But we have also seen continuous improvements in small steps, in different AI technologies, in methods and processes in building knowledge, and also have seen some quite big and quite nice success stories. For example, use of AI in development of COVID-19 vaccine. So where are we today? I can show you day by Gartner hype cycle, particularly for artificial intelligence. And it's interesting to see in general, where are the big expectations and where are already the solutions and where we have started approaching the realization of our previous expectations. So I will start with these two areas, composite AI and AI orchestrations and automation platform. What it is? It is about using AI solution and integrate them in a complete solutions, integrate different solutions of AI in a new functionality. So it's a lot about integration. So I think that there are bigger expectations now from the system which are able to integrate different functions of AI, not a particular AI function. And we know that, like autonomous driving, it's not AI functionality, it's not recognizing face. Similarly, we can see here a big expectation of efficiency and good results in model ops, which means a developing model of machine learning models, which actually means the development process of the system which are using AI functionality. So from an efficient model and process, we can achieve much more than we can achieve today, which is required. So not only on the prototyping level, but on the real operational and use of AI. So these are big expectations. On kind of the top of the curve is related to edge AI. So edge AI is AI trained and operate in a distributed environment on edge devices with smaller computational power, but integrated in a distributed network. With huge expectations. And now it's time to realize that. And now it's a time to see what is possible and what is not possible. Related to that, we have some activities here, which are specified, but which are actually already in dissolution phase, which means that we have realized that not all we have expected is actually possible, will be done or is done in a very bad way, not proper way. The first one you can see is AI cloud services, which are more limited than we have expected because of different constraints, because of the resource constraints, because of the traffic constraints, communications constraints, because of the security questions, and similar. We also have here like the solutions of expectations of technologies like deep learning in general, natural language processes, machine learning. So many of our expectations were unrealistic, but we are approaching way when we are realizing what is not realistic. We are still on the way to find what is realistic. Similar, you can see here is related to data labeling and annotation services. It's still more complex and more difficult to do this than it was expected before. And the last one, which I want to show here, is autonomous vehicle systems, which is actually like past this bottom part of the curve of this solution and is increasing now in expectations, which is more realistic. And that's nice. That's nice because actually what we want to be here at the end of the plateau of productivity, when we can realize our expectations. And of course, we in the center and researchers and companies would like that this gap between expectations and beliefs that what is not possible to realize is small, and that this disillusion period is short, and that we actually come to this saturation curve much earlier and have a lower gap here. So this is about different areas. But what about the type of challenges? Maybe independently of concrete application or functionality or area, what are the problems today? So this is one investigation from 2020, so quite relatively recently. And you can see, according to that investigation, the biggest problem is related to integration. I would say here, deployment and integration, put into operation the system, integrate AI functionality with the entire system. That's the biggest problem what companies have faced. Not to build a particular prototype, but actually to use it properly in the operation. The other problem is related to data, and that's quite known today. Access to data and in general management data is complex. It requires a lot of efforts. It requires a lot of changes in the processes, in the knowledge, in the technologies. And it is known that most of the efforts in this entire process goes to the access and management data. Probably that will last for several years until the processes are properly defined and even data are collected and standardized the way how to collect them and how to define them, how to use them. The third question here, the third challenge here is related to cybersecurity privacy. And I would say why understanding of privacy is increasing and probably it will lead to some standardized solutions. The cybersecurity, which is against attack, malicious attack to the systems, will be continuously important and maybe increasingly difficult to manage. Because, of course, the attacks, they are using the same technology, the same knowledge, which the cybersecurity is using. But the last two, which you can see here, are very interesting because they show about the maturity of using AI. So not only building prototypes and building functionalities, but actually showing how does it work in the operation, how to maintain such systems, how to provide evolution of such systems, how to manage them in general, and what are the costs, and how to predict these costs. And these are typically questions which are not directly AI development questions, but related to AI engineering. So that's one of the things which are very important for us here. So let me show you some of the challenges we have found out in companies, and that also depends of type of use of AI. Maybe we can relate that to the maturity of use of AI in the companies. Of course, when companies start to use AI, they need to find out the feasibility of this approach of using it, which leads to experiments and prototyping to find in which way is the best way for using from the business point of view, from the efficiency of development and so on. How to express the requirements into data and the machine learning models and similar. Then you can come to the non-critical deployment, which means start to use AI in applications which are not critically important for the company, for the business or for the customers. Next stage is using AI in critical applications, so critical deployment. So, and the last stage is related to reuse, continuous use, and improvement of AI, so cascading deployment, so using solutions and adding new solutions. And when looking at companies being in this different phases or different organizations within companies in different phases, and looking at the AI development process, not complete process, but related to the machine workflow. So from the collecting data, creating models, train it and evaluating, and to finally deploy it, put into operations. So we have analyzed the type of typical challenges or the most important challenges the companies meet, and you can see them here in this table. I will not read all of them, just to mention some of them. Maybe, for example, looking for no critical deployment. When it's related to data, then you have questions of data silos, so different data stored and managed separately, and it's very difficult to integrate them. Imbalanced training set, so in general not well prepared data for machine learning, which means a lot of work before you actually start building your model. So if you come to create model and training and evaluation model, then there are problems related to the validation, in a sense, from the business perspective point of view. While you can evaluate your system related to some technical characteristics, like, for example, accuracy of the system, there are no theories and no proper ways. How do you evaluate your systems related to the real requirements for the system, for example, for the business requirements? Similarly, you know, if you look like challenges related to particular phase in the activity of the life cycle, like, for example, in training and evaluating model, you can see different type of problems, of course, depending of different type of use of such of AI system. For example, for a critical deployment, it is quite a big challenge to reproduce models to get the same results, even if it is the same context, the same input data. If the machines are different, for example, you can get different results. What are the equivalent context? And similar are huge problems to make it possible to run these applications, these solutions in critical applications. So here you can see typical problems, list of problems which we have collected. You can read them or you can read them also in the paper down. But related to these questions and other questions, we have developed a framework which identifies different type of challenges and problems the companies, the industry have while building AI systems. And we call that AI engineering, as you know. There are parts which are valid in general for any type of AI system. And there are other parts which are specific to particular domains. For example, safety critical systems have specific requirements on safety, security could be, some other related properties. And then is a question how AI systems are behaving in relation to safety requirements. Either how they fulfill the already known requirements from safety critical standards for such system, but it is also a question of coming with the new requirements. And as you can see here in the AI engineering part, there are different parts which identify types of the problems. For example, related to the architecture or related to development, in particular building up a model for building using data or machine learning process, or related to the quality attributes. I will show shortly these two examples here, data ops and quality attributes, or integration of development process for software with the development process of machine learning functionality. We know about this known DevOps model, which shows an integrated process between development environment and operational environment, and which makes it possible continuous exchange of information using continuous deployment and monitoring during the operation and providing information to the development environment, which then can be able to introduce new changes, do testing and build and do testing and again redeploy the new system. So how such system is possible to integrate with the machine learning workflow, which is shown here, which is like typically consists of data management part, ML modeling, and ML operation. How do we integrate such a system? How do we build an integrated and flexible system when we are changing software? How can we change the ML model? How shall we change the data? So this is one type of the question. The other type of the question is, how do we ensure that the context in which our system is running is equivalent to the context in which we provide the machine learning? Of course, one solution could be that this is the same environment, so that our training model, for example, using reinforcement learning, is actually running in the runtime environment. And this is, of course, a nice solution, but it has some limitations because it requires additional resources. So that's one big problem. And there are also other solutions, but these are like typically type of the problems which we are asking in relation to development process and the integration of software development with the machine learning process. Or I can mention another one, relation between system quality and AI quality. You know, the system quality is defined by a number of quality parameters. For example, one is reliability. which is valid for an entire system. And then we can ask the question, when we are developing a particular component, as you can see here, we can see a system which has its architecture. It has, which can be different, but in this case, anyhow, you can see we have functionalities, components, which can be of AI character, so building as AI components or not. And we can state a question for a specific requirement on the system level, what kind of requirements we have for the components concretely. For a reliability required for a system, what kind of reliability of other quality we need to fulfill on a component level. Is that accuracy, for example? So the number of correct predictions divided by the number of attempts of predictions. So these are questions which are not yet solved. So we know approximately the way how to do this, but it must be done, and it must be seen how does it work in practice. So for this reason, it's extremely important, this cooperation, you know, that building up the models and the processes and see how do they work in the real environment. That is the goal. So I can conclude that we can expect a number of projects related to AI engineering at the Software Center in the next few years. That's for certain. It will be very, very important. So you can see a list of some of the areas of the projects. That list is larger. And I would like to conclude this presentation with showing you possibility to get to know more, not only from Software Center, but from the world community, from the experts from other companies and researchers. Software Center is the main organizer of the conference AI Engineering, so it's the first international conference. And it will run this year in May as two parts. One is online, May 16, 17, and then one part in person, if you like directly to meet experts and want to discuss to them. You can do that as well. And of course, you can participate, or you can submit a position paper or propose an industrial talk in which you talk about your experience or problems, or submit research and experience papers. And here you have the web page for more details. And by this, I would like to complete this presentation. And if I'm here, then I will be happy to answer to your questions. If I'm not here, then Jan will be happy to answer to them. So thank you from my side.